Okay, hello everyone in a new video. So in this one we are going to start a new chapter, which is chapter 7, the voltage of the mains, and the second unit of electricity. Previously we have discussed notions related to electricity in a simple electric circuit. Now in this chapter we are going to discuss notions related to electricity but in domestic installations. So what do I mean by this? So if you consider the following document, these are connecting wires along which electricity is being transferred, and they are connected to the house. So the voltage is being supplied to the house across these connecting wires. Okay, so now in this chapter we are interested in studying how electric appliances are connected inside the home and what are the properties of such type of voltage and how can one protect domestic installations. So in order to do so, let me start by the first section, which is section number 1, the male and female terminals. Now, as we have seen in the previous documents, after the voltage is being supplied to the house, we know that we can make use of this voltage, which is said to be the voltage of the mains. So recall that this voltage, we call this voltage. So coming from these wires, this voltage is the voltage of the mains. The voltage of the mains, which is the title of this chapter, okay? So we make use of this voltage by connecting electric appliances. So this is the plug of an electric appliance, and this wall outlet, this is the wall outlet, which supplies the voltage of the mains. Okay, now in order to make use of this voltages, which is voltage of the mains, we connect the plug of an electric device here. So usually we call this terminal to be the male terminal and this one to be the female terminal. Okay, and as you can notice that, just a side remark, since we don't distinguish between the positive pole and the negative pole, so the first thing that we can say that the type of this voltage is given by AC voltage. Okay, yet we didn't know whether this voltage is sinusoidal, triangular, or even square voltage. Okay, later we will discuss these properties. Now let's talk about this outlet, and let me write section number 2, which is the wall outlet. So all of us are familiar with two types of outlets. So the first one that consists of 3 terminals, and the second one that consists only of 2 terminals. So in the case of the 3 terminals, one of these terminals is said to be the live, the second one is the neutral, and the third one is the ground. As for the other kind of outlet, it consists of 2 terminals in which one of them is the live and the other is the neutral. So So I suppose that we are familiar with both type of outlets. Let me write idea number 1, which is given by the voltage of the mains. So recall that these wall outlets provide the voltage of the mains. So the voltage of the mains supplies across the wall outlet, say for example an alternating sinusoidal. So here I'm giving the properties of this voltage. of effective value U effective is equal to 220 volts, and of frequency F is equal to 50 Hertz, and this is known as the electricity of Lebanon, EDL. Delivered through the wall outlet. Here what I'm saying is that what are the properties of the voltage of the mains? So it is alternating sinusoidal voltage. Its effective value is given by 220 volts and the frequency is equal to 50 Hz. So one should memorize these properties. Okay, so the voltage in Lebanon, it is alternating sinusoidal voltage. Its effective value 220 volts and the frequency F is equal to 50 Hz. So why one must memorize these properties? Because this is important whenever it comes to choose electric appliances, because we know that each electric appliance has a certain indications and it won't function normally unless it has the same indication. Now let me write idea number 2. The live terminal is the one responsible for the transfer of the current from high potential to low potential. Now I will explain, or let me say even in other words, the live terminal is responsible for the voltage. Although here in this case we are not distinguishing between the positive pole or the negative pole, even for this one we are not saying that this is the positive pole or the negative pole, but here it's important to distinguish between the live and the neutral terminals. So the live terminal is the one that causes causes the transfer of electricity. So it is important to distinguish between the live and the neutral. It doesn't mean that the one on the left is the live, and it doesn't mean that the one on the right is the neutral, but later on through the chapter we will discuss how to distinguish between the live and the neutral terminal. So here we should know that the live terminal is responsible for the voltage. Okay, so it doesn't mean also that the neutral has no voltage. Okay, but for the time being, let's consider that the live terminal is the one responsible for the voltage. Okay, and previously I have said that the effective voltage is given by 220 volts. Suppose we want to make sure that the voltage supplied from the mains is being by 220 volts. So how can one can measure this voltage? Simply this is done by using a voltmeter. So using a voltmeter, one can measure the voltage across the outlet, and one can make sure that it's given by 220 volts. But first, the voltmeter must be adjusted on the AC mode. So let's say a voltmeter adjusted on the AC mode indicates. So let me say here we have idea A, idea B, idea C. So now the voltmeter, we know that the voltmeter, it has two terminals. So now forget about the COM terminal here, because we are not distinguishing between the positive or the negative pole. So for example, we can connect the voltmeter like this, or we can connect the voltmeter like this, or even we can connect the voltmeter like this. Okay, and depending on each connection, the indication of the voltmeter will be different. Now let's take the first case here, because we are saying that the live is the one that causes the voltage. So suppose that we connect one of the terminals to the live and the other to the neutral. So we expect that the voltmeter must indicate 220 volts, and this is because one of the terminals is connected to the live. As long as one of the terminals is connected to the live, then the voltmeter will indicate 220 voltage, because we know that the voltmeter in the AC mode measures U effective. And let me say 220 volts if connected between the live and the neutral terminals. Okay. Now, in order for the voltmeter to indicate 220 volts, one of the terminals must be connected to the live. So previously what we have done is that the other terminal, we connected it to the neutral. Now similarly, if this is connected to the ground, will also indicate 220 volts. Now the last case that we can consider here, if the voltmeter is connected between the neutral and the ground. So notice that none of the terminals is connected to the live, which is responsible for the electricity. In this case, the voltmeter will indicate 0 volts, no indication. Now what about the case where in which we have two terminals? Here if we have the voltmeter, so this is connected here and the other connected here. We are not distinguishing between the COM and the other terminal. In this case, one of the terminals is connected to the live. We know that the live, from its name, it's the one responsible for the voltage, so the voltmeter will indicate 220 volts. Okay. So from here one can deduce, since the live is the one responsible for the voltage, so before we proceed, it is an important thing in order to distinguish between the live and the neutral terminal, and this is done using an instrument called the screwdriver tester. Okay, so probably most of us are familiar with this one. So notice that in this case here we have a plug, but this is not a wall plug. So in this case, as you can notice that here we have the connecting wire, and this connecting wire is connected to the wall outlet, something like this. Okay, so notice that in this case it consists only of two terminals, so one of them will be the neutral. So if we refer back, so we are in this case. So in this case, one of them is the live, one of them is the neutral. We cannot say that this is the live or this is the neutral based on the fact that one of them is on the left and one of them is on the right. So in order to distinguish between the live and the neutral, we use an instrument called the screwdriver. So when the screwdriver is inserted in the live terminal, because it delivers the electricity, inside this screwdriver there is a lamp, and notice that in this case the lamp is functioning, so it's glowing, which means that this is the live terminal, this is the one that delivers electricity, okay, responsible for the electricity. Now when we place the screwdriver in the other terminal corresponding for the neutral, notice that the lamp in this case doesn't glow. Then let me write down, we are in section number 3, and the name of this instrument is given by the screwdriver. Tester, or even sometimes we name this instrument to be the live main indicator. And let me write idea number 1, which is given by the screwdriver tester. So this is one word. Or the live main indicator. Is a device which allows us to distinguish. So, and here to distinguish, it means to check the difference between, or to differentiate between the live and the neutral terminal. Now in number 2, so here inside of this screwdriver there is a neon lamp. It consists of a neon lamp that glows, and here the neon is a special type of lamps that glows when subjected to a voltage greater than 80 volts. Now, why greater than 80 volts? Later on we will check that this voltage may cause electrocution, which leads to death. While holding its extremity with the finger. So as you can notice that this is an effective voltage greater than 220 volts, and he's holding the extremity with the finger, placing it the live terminal so the neon lamp will glow, which means that this is the live terminal and the voltage is greater than almost 280 volts, and this is true because it is 220 volts. So this is it for the screwdriver tester or the live main indicator. Now let's move to the next section, which is the domestic installation. So this is and let me write here idea number 1. But before, let me explain that domestic means related to houses. Okay, so now considering this figure, what do we notice? So this is the voltage of the mains. So as we have seen previously, that the voltage of the main is given by that. So this is the voltage of the main. Now it's being connected inside the house. Now there is an electric meter, then we have the circuit breaker, then we have the differential circuit breaker. Now for the time being, let's ignore these instruments or electric components, and let's focus on how the electric appliances inside the house are connected. So suppose that this house consists of a TV, a lamp, an iron, an air conditioner, and a washing machine. Okay, and here we are talking. Okay, so now let's forget about the third wire coming from each electric component. Let's forget about them. And now if you can notice that it's not completely clear, but let's try to check that each electric component has two wires. So are the two wires of the TV, these are the two wires of the lamp, these are the two wires of the iron, these are the two wires of the air conditioner, and these are the two wires of the washing machine. All of these two terminals are connected to the voltage of the mains. So these are the voltage of the mains which end up here. So all of these are connected to the voltage of the mains. So they have two terminals in common, which means they are connected in parallel. So the first thing that we should know that electric appliances in domestic installations are connected in parallel. Or before saying so, let me say how do they function normally. Then electric appliances connected. Okay, let me say that here this voltage is 220 volts and the frequency is given by 50 Hertz. So here for sure at each one we have a wall outlet. So basically these electric appliances are connected to wall outlet, and the wall outlet, these are the wall outlets, and the wall outlets are connected back to the voltage of the mains. So connected to the wall outlet are functioning normally. So why they are functioning normally? Because we make sure that all the electric appliances we install in our home, they have an indication given by 220 volts and 50 Hertz. of effective value and of frequency f is equal to 50 Hertz. Now idea number 2, as I have mentioned previously that these electric appliances, let me say electric appliances, and by the electric appliances I mean the TV, we have also the lamp, we have the iron, and we can list them all, given by the washing machine, the air conditioner, so are connected in parallel. In order to function in order for each. This is extremely important. So in order for each to function independently, so the functioning of each of these electric components is independent of the other, and by this I mean that so this house may consist of several rooms, and we know that if we turn off or switch on the switch in one of the rooms, so the lamp will turn off, but this will not, so I mean in another room we can switch the lamp on, so the functioning of the lamps in one of the room will not affect the functioning of another lamp that exists in another room. Okay, by this we mean that the functioning is independent. What I mean here is that if we have two lamps, suppose that they are connected in series and they have one switch between them, and another grouping in which they are parallel, but across now each lamp we have a switch. Now in this case, in the series connection, if this switch is on, so both lamps will be switched off, but in the parallel grouping we can independently function the lamp L1 or the lamp L2, and this is related whether the switch, if this switch is open or closed. If this is closed, so L1 will function, L2 will remain open. If this is closed, L2 will glow and L1 will not function because this switch is open. For this reason, all domestic installations are said to be under parallel grouping, or in other words, all electric appliances in domestic installations are connected in parallel. Now the third idea is that for example, now we know that all of these, so the voltage of these electric appliances are given by 220 volts, 220 volts, 220 volts, 220 volts, 220 volts. So what's the difference between one electric component and the other is the current I, or instead talking about the current we can talk about the power. Then the total electric power P total consumed by the domestic installation is the sum of the electric power consumed by each electric appliance. And now in this case the formula is given by P total. So I repeat, in idea number 3 we are interested in calculating the P total. So the total electric power consumed by this grouping. So the total means the sum, so we simply add the P of the TV plus P of iron plus P of the air conditioner. I will say, okay, let me write air conditioner plus P of the washing machine. Okay, so in this case this is the total power. So did I miss anything? Okay, and we have also P of the lamp. It's not important whether we place TV first, iron, lamp, then this. Okay, so the order is not important. So the total power of this domestic installation is the sum of electric power of all of these electric components. Okay, and we don't discuss the electric power of the electric meter, the circuit, the differential circuit breaker. So starting after the differential circuit breaker, we start to add the power of these electric components. They are given by 5, so we have 5 terms. Okay, now in this case we can calculate the P total. If all of these are expressed in watts, so the P total will be expressed in watts. Knowing the value of P total and knowing the effective voltage, one can determine the value of the main electric current. Of the domestic installation. Is given by P total is equal to U effective multiplied I main. Here we are talking about, okay, so we know that if we are talking about U effective, then I must be effective, because here we are talking about voltage of the mains and not a simple electric circuit. So let's name the current, electric current, to be I main. So we are interested in determining I main. In this case, then, so if we construct the triangle of this formula, P will be at the top, U and I at the bottom. We are interested in determining the value of I. So I main will be given by P total divided by U effective. We know that in this case, in Lebanon, the voltage of the mains supplied to the domestic installation have a value of 220 volts, and we can determine P total by adding the power of each electric component, dividing P total by U effective. One can calculate the value of I main. So now let me add idea number 5. So please write down this idea because it doesn't exist on your notes, and let me say that the main electric current can be also calculated using the law of addition of currents. Why the law of addition of currents? Because we know that electric appliances and domestic installation are connected in parallel, so we can apply the law of addition of currents. So parallel connection. In this case, I main is equal to I of the TV plus I of the lamp plus I of the iron plus I of the washing machine plus I of the air conditioner. Okay, so now we have two different ways to calculate the main electric current traversing a domestic installation, either using this formula or even using this formula. And here let me underline or highlight. So this is another formula. And let me highlight this important statement that one should memorize. Whenever they ask us why they are connected in parallel, our answer should not be in order to have the same voltage, but rather in order to function independently. I repeat, whenever they ask us why they are connected in parallel, so why they are connected in parallel, the answer should be in order for each to function independently. We don't say in order to have the same voltage. Okay, it is wrong. They are connected in parallel because in order for each to function independently. So that's it for me in this video, guys. In the next part 2 of this chapter, we'll continue the explanation and solve exercises as a direct application.